Welcome to another physics class. In our last lesson, we were talking about measurement in physics, and I promised today to move to measurement of length. But before then, let's look at time. Time. What are the possible instruments to measure time? Time is the period elapsed between two events. Then what are the possible instruments to measure time? 1. We have stopwatch. 2. Stop clock. 3. Sand clock. 4. Ticker tape timer. 5. We have simple pendulum. Number 6, heart beat. The heart beat can also be used to measure time. The heart is beat 72 beats per minute. So that's one also is used to measure time. This is number 7, is atomic clock. Atomic clock. These are the possible instruments that we can use to measure time. The next one is speed or velocity. Speed or velocity. The possible instruments to measure speed or velocity are 1. Speedometer. 2. Radar gun. Then 3. Velocity sensor. So these are the possible instruments to measure speed or velocity. The next one, which is number 14, is energy. And the possible instruments to measure energy are 1. Energy meter. 2. Spectrophotometer. 3. Calorimeter. So to measure energy, these are the possible instruments. But mind you, all these quantities that were mentioned and they are possible instruments, they are topic on their own, which we are still going to treat in the future. Now, the next one, which I promised before, is length. What is length? It simply means the distance between 2 points. Now, what are the possible instruments to measure length? 1. We have meter rule. The meter rule in physics is divided into 2. 1. We have uniform meter rule. This one with maximum length 100 centimeter. And the second one, we call it half meter rule. This one is 50 centimeter. That is half of 100 is 50. Now, from what we have written on the board now, we can now say that meter rule is graduated in centimeter. Meter rule is graduated in centimeter, and the accuracy, that is the reading accuracy, the reading accuracy of meter rule is 0.1 centimeter, or rather 1.0 millimeter. Since it is graduated in centimeter, so 0.1 centimeter convert to millimeter, multiply by 10, it will be 1.0 millimeter. That's the reading accuracy. Or in another way, it can be also called the least measurement. The least measurement that meter rule can take. And then when you are using meter rule, the least measurement that you can use meter rule to measure is 0.1 centimeter. 0.1 centimeter. Or in another way, you call it the least error. The least error that can be committed when using meter rule is 0.1 centimeter. So these are the possible language which we use for reading accuracy, least measurement, and the least error that can be committed. The same value, 0.1 centimeter, 0.1 centimeter. Now, meter rule is used to measure the length of an exercise book. Any short distance like the length and breadth of an exercise book, meter rule can be used to measure such measurement. Now, meter rule, as I said, it is graduated in centimeter, and when you show this is 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one will be 1. In between 0 and 1, there are 10 spaces. Each spaces will be 0.1 centimeter. 0.1 centimeter divided by 10 will give us 1. Rated in centimeter all along like that, depending on what you want to measure. The space we have in between them is 10. Then each space is 0.1 centimeter. 0.1 multiplied by 1, that will be multiplied by 10, it will be equal to 1. So that's 1. Continue like that up to 2, up to 3, depending on what we want to measure. Then number 2 instrument to measure length. Number 2 is tape rule. Tape rule. This one is used to measure any distance or any length that meter rule cannot measure. For instance, length and breadth of classroom, that one cannot be measured with meter rule, so we can use tape rule. Another example is length of a playing field. Meter rule cannot be used to measure that one also, so we use tape rule. So and many other. Any length or distance diameter rule cannot be used to measure, we use tape rule. And tape rule is graduated in meter. Because of the long distance, it's graduated in meter and centimeter. That is for tape rule. There are three instruments that we can use to measure length is vernier caliper. Vernier caliper. Now, to use vernier caliper, it's used to measure short distance. When you compare with length, the one length cannot be used to measure, which is very short, then we use vernier caliper. Example is diameter of a sphere. We cannot use meter rule to measure that accurately, so we use vernier caliper. Internal and external diameter of a tube or any test tube. So let's list the uses of vernier caliper. Uses of vernier caliper. One, to measure the internal and external diameter of a tube. That's number one. Number two, to measure the diameter of any hollow material. Any hollow material. Number three, to measure the diameter of a sphere. Example of sphere is ball, orange, globe, etc. Any sphere material like egg and so on. So these are the possible uses of another one. Number four, to measure the diameter of rod, like iron rod. We want to know the diameter. We use vernier caliper. To add more, number five, to measure diameter, of a plate or disc. So we use vernier caliper to measure the following. Now the next thing is how to read or use vernier caliper. How to read vernier caliper. The first thing we need to know the accuracy. The accuracy of vernier caliper is zero. Accuracy of vernier caliper is 0.01 centimeter. This means that vernier caliper is graduated in centimeter. Is graduated in centimeter. Then the least measurement, the least measurement, vernier caliper can take is 0.01 centimeter. It has two scales. It has two scales. One, main scale. This one has fixed value. It has fixed value. Then two, vernier scale. This one is adjustable. Or move over the main scale. The vernier scale has 9 divisions. Each division is, according to the accuracy, is 0.01 centimeter. Now, the next thing is, let's see example. The first one that I will show is zero reading vernier caliper. Zero reading vernier caliper. Let's show the diagram. Now, this is the diagram of vernier caliper. Here is the main scale. And this one is the vernier scale. If you count the number of lines on the vernier scale, I say it has 9 divisions. This line is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisions. Each division is 0.01 centimeter. So when you now say zero reading vernier caliper, the zero arm of the main scale is on zero arm of the vernier scale. That is why we call this one zero reading vernier caliper. It means this vernier caliper now has not taken any reading at all. Look at this number 2 example. Says, what is the reading of vernier caliper below? The first thing you need to look at is the zero arm of vernier scale, where it lies on the main scale. And from what is on the board now, let's look at it. This is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. It means the zero arm of this one is like between 0.6 and 0.7. But it's not up to 0.7. You now read the main scale as 0.70. Now, for the vernier scale now, it has 9 divisions. Now look at it, where we have the overlapping of the main scale and the vernier scale. You can see what is on the board now. The point of overlapping is more than 1. Let's count it. 1, 2, 3, 4. We have 4 places where we have the overlapping. But we start from the zero arm. The first one, the first overlapping is the correct reading. So it means If you want to take the reading now, you take the reading on 1, 2. This one is 0. So that will be 2 for vernier scale. But the accuracy is 0.01. You now multiply by 0.01. And the answer to this one will now give us 0.02. Add this one to this one, that is 0.02. Add everything together, we are going to add 0.72 centimeter because it is graduated in centimeter. That's the answer to that one. Now from this sample 3, what is the reading of the vernier caliper below? Here, the main scale is 4, 5, 6. Let's look at the vernier, the zero arm of the vernier scale now. So let's count it. This one be 4.1, 4.2, 4.3, 4.4. It means the zero arm of the vernier scale is between 4.3 and 4.4. So main scale will be 4.30. Now to take the vernier scale now, let's look at it together. The verse overlapping is on this. The second one is on this. Now this is the third one. And I said you should pick the first one from zero arm. So this is the first one. Let's count it. The 0, 1, 2, 3, 4, 5, 6. That is 6. Now 6 multiplied by accuracy 0.01. And this one will now give us 0.06. So the vernier scale now will now give 0.06. Add together, our answer will be 4.36 centimeter. Let's take this one as the last example under vernier caliper. Look at this one now. The vernier scale is here, but the first value on the main scale is 7. But according to this diagram now, part of it has been cut away because the vernier scale is beyond 7. Now, if the next number before 7 is 6, so if we count back, this one will be 7, 6.9, 6.8, back like that. It means the main scale now will be between the 7, 6.9, 6.8 will be between the 6.8 and 6.9, but it's not up to 6.9. So the main scale now, main scale will be 6.80. Why? The vernier scale. Let's look at it. 0, 1, 2, 3. We have the first overlapping here, second one here, another one, but we must pick the first overlapping. That is 1, 2, 3, 4. That will be 4 multiplied by 0.01. The answer we give is 0.04. Add it to this one, 0.04. So our reading for this one will be 6.84 centimeter. And with this series of examples under this vernier caliper, that is how to read it. If you are given any question, especially in objective, you should be able to read it correctly and pick the right answer. In the next video, we are going to micrometer screw gauge. As we study the vernier caliper, we look at micrometer screw gauge also, how we can read it, the accuracy. But if you are new to this channel, then you need to subscribe, share, and like for you to get the notification when I upload new video. Thank you.